All right. So the last video dropped again. So I'm going to redo some of this. So the inside skin is piezoelectrics with a rubber compound that has a electrically conductive, so it's insulated with these little coils that are, fairly small for what they are, that allow for a degree of push from the front skin with that hydraulic fluid, and then the electricity that passes through, and a field effect because it's electrically conductive. Now, the reason why I was talking about this was because I need that wire, and the compound that I was talking about actually is electrically conductive with iron and some other, because it's a very thin iron, so like the iron can be conductive with the correct alloy. And as a result, when it's structured like bone, it allows for when impregnated. Hold on. Right, so I thought about iron, and then it's like iron doesn't really work. I'm not using the iron cobalt with hydrogen. I don't want it. That's for the batteries that you breathe into, and as you stretch and strain, it creates its own version of a pump that, as carbon dioxide comes through, because of the way it's built, it actually rips off the carbon and then allows for the oxygen to be freed. But in so doing, it produces heat. It's an alloy that basically is a carbon filter. But at the same time, like, you have to eventually, because you lose hydrogen. If you don't know, like, you'll eventually lose your hydrogen. So you have to re-impregnate it with hydrogen every few months, depending on, like, your breathing rate and exercise and all the rest of it, and it produces electricity with the piezoelectrics and everything. And I was like, cobalt's kind of fucking, carcinogenic. So, I was like, it's got to be another way to do it. And that's when I was like, the battery capacitor design for the car came about. So that worked out fairly well. You know what I mean? But it's okay, like, basically, as you breathe, you'll have a moment in time where the skin for the piezoelectrics and while that coil happens to be right, like, micron distance from your skin to touching, because, like, you need pressurization, so it has microns, and it's really rather form-fitting, but that's how you get the charge field, because it, like, tends to create that little electron charge field gap that tends to make these little itty-bitty tiny little static charges. But for my purposes, it breaks down carbon dioxide / water, and as it goes back into the battery, it tends to recirculate and keep it going, but you have to wait for a few hours, and you only have a few hours of it being able to do that with the charge differences. But I need to get back into that dang compound. What was that dang compound? So it basically, it'll rerun itself, but, like, you're the battery for the battery to charge up the battery for the battery to keep charging you up, that kind of thing. It's kind of like an organoid suit system. That's how I designed it, like a suit that's an organism for you, but a synthetic version. So that's kind of what that is. But then I was like, all right, we're not quite done. I need to make this compound. And like, I had it back in the day. What the heck was this compound? It's not iron. I got rid of iron because iron wasn't working. I had to use, like, a tungsten carbide. Is shitty as fuck. It's really quite heavy. It was something novel, like basically a version of like, you think about trees. It's like, let's put it this way. I made, like, this compound that basically, in my mind, of course, I haven't made it, but out of, like, peanut shells, the debris from e-waste, and some, stuff like that, alongside of fecal matter, when it slides down over a lot of heat, and then it goes into, with the right degree of reflective properties from mirrors and so on, it tends to carbonize, but then also with fat and other minerals produces a very hard, very not porous when it slags into itself, and it produces a great deal of heat as a bed. And on the top might be a little porous, but it continues layering. And you get enough heat from the sunlight, and you put argon in it so that way you get rid of the oxygen from extraneous sources. You're then able to heat the argon up, and then you're able to allow for the sunlight to effectively filter through at the correct wavelengths and everything that you want to look for. It produces this very hard material from fatbergs, and which have a lot of organic, other mineral, and other stuff from, and they're usually plugging up our sewage system. So I'm like, that's 2 birds, 1 stone right there. Just shove it in, be done with it. Here's some e-waste, for you from some silicon. And I was like, that's not too hard. And shove in some peanut shells and some rubber, and off to the races. And it's a fairly strong structural support exoskeleton, as I like to call it. That's fairly bendy for the inside pumice stone, steel wire, like the scrub your pots and pans with, and then a what was it? What did I use again? Fart. I think it was limestone, or like that volcanic stone or something like that. Like basically a really porous structure that has a very hard, and then like you pour it together, and then like it slowly hardens with this material, and the wire basically allows for that to ablate if it ever gets hurt, but then like it can also reform because it's an oxidized compound. But then that was the silicon. The other one doesn't have the silicon. That one has the silicon. That's the one that it was. That's the one that has the silicon in it. That's the like, I'll just pour whatever silicon or some other garbo, because it's like, that's e-waste for me that I can just use. I don't really have to do anything but then grind it down, and it'll work just fine, because it'll go into this porous structures, and then like with the right slurry, and then like slowly evaporating the water, or you heat it up a little, it'll produce a good concrete for a fairly cheap price. And then you exoskeleton with the rubber and the peanut shells, and which is like, why peanut shells? And it's like, peanut shells are very porous and they have very long strands. If you've ever seen like the Mythbusters episode with newspaper that they freeze, pretty strong at stopping bullets, but then like, rubber is not very strong at that. But then like peanut shells correctly placed together with this really hard, but still rather flexible for, tensile strength compression stuff, and then you mix it together, and then it's like, it tends to make a good, decent exoskeleton. So I was like, I wonder if I can build upon that design for making a basic, bone kind of, it's like, which by the way, it's like, so weaving threads is really, really like, you have to wrap them around a central core, but you don't want this to be a central core, okay? So like, these are just plates that go interspacively. So think about it dimensionally. I need you to wrap your head around some dimensional topics here. You gotta basically make not a honeycomb, but like, think honeycomb structure around this sinew, essentially, which makes a version of bone and sinew, with the strands going through actually the honeycomb, parts like that are like that, and it goes through that, but then it's like also it'll go through the holes of the honeycomb. And then now you have the design effectively that allows for flexibility and slide and degrees and measuring of a kind of spring, which is why iron wasn't not terrible, but then I was like, iron's kind of terrible. And then it's like, what was that metal stupid strand thing? I know it wasn't magnesium. I know it's not titanium. I know it's not really iron. I know that for a fact. It's like, what was it? Dang. I wish I remembered. anyways, point is, it's like cobalt's okay, it works out, but then it's like this battery's a lot better. But the problem is it has a runaway effect. You have to cool it a hell of a lot more because it'll continuously create from that potassium and all the rest of it a measurable degree of increase of heat. And so that's why cobalt was kind of like the king. But then like this will actually still do it. You just need like to shrink it down a little, you know, and allow for a greater degree of surface area. So like plates kind of became a thing. Anyways, and then the rubber that has the piezoelectrics that then also stretches and strains, and those little, you know, coils, which I was like, coils are annoying. Like diamond-like carbon's fairly easy to produce, you know, in like the right little way to make the double coil strands, you know, that allow for a press and then a heating up of the element, and they should still work and be insulated inside of the rubber, especially with the hydraulic fluid that will also act like a blood that you pump around, you know, allowing for maintaining heat in your suit, which your battery also happens to. My battery, I'm imagining you, I switched into you talking to me if you were ever watching it. Anyways, point is, it would be the heat from the battery that you're also, you know, exchanging with that band gap, you know, radiator, you know, as you goes through to continue, and like the remainder goes out into whatever atmosphere you have, or radiative concept as well, for that to be effective and efficient in allowing for maintaining of heat and pressure inside of the suit, form fitting, and then there's the exoskeleton design that I also put in, which is a liquid crystal non-Newtonian fluid mixed together with a little bit of hydraulic fluid that it's electrically conductive, which allows for the liquid crystals to align in very specific areas, because I can, you know, use nerves essentially to allow for it to now I have strong, but not where the inside between the three, for the 3-piece, you know, 2 skin and bone and sinew blood combo. Like this is actually like its own thing. You just use nerves to get to it because it's easier. And then like an analog light based sort of design that then projects into like. So have you ever seen an S trap? You know, for you know, any exhaust or fluid, it's like actually I can use that for light or particles. If I use light that reflects appropriately and is properly at the end corrected with a proper correcting lens and amplification light crystal, then I have a light that can come through that looks basically trapped. It's a one-directional light. There's no reflection. And then you can also use that for electricity generation, but also it stops charged particles and very fast moving particles, because it can also be, hey, we have this wonderful clear plastic that happens to be electrically conductive. And so if we happen to use that, then we can create charge fields with this electricity and so on that we're producing, along with this massively dense, it's not very dense actually, but it acts like it's dense because it has a bunch of stuff interspaced in between every single, you know, like take a hole and there's a bunch of little dots everywhere around there, but then it all just gets filtered to you as normal. We have some, you know, amplification and so on, sure, but it does like to, with the correct thickness, stop the majority of particles that are going through space, and then has electromagnetic and charge fields that happen to help you with preventing those things from hurting your face holes, which is good, I feel. You know, good old face hole protection, typically, you know. And then you just put like a little dot matrix on that outside that then allows for you to go like, hey, this is me on the inside. And you'd never even notice that there's a clear black hole behind that thing, because that's what it'll look like. It'll look like a black hole. No light escapes the other direction. Effectively, there's no real light that's going to go back that way. I mean, there's a little, but like very little. You know what I mean? So, you know, which is a good thing, you know, typically. But anyways, that heat and everything else gets, you know, it's like, what the hell is that dang compound? I think it was just something that I'd forgotten, obviously. I think it's just, like, calcium would work. It already naturally wants to do it. Calcium is like not the right structure. Or like a very strong ceramic that's able to be kind of like sapphire, where it's actually able to be electrically conductive. That happens to have. That's why I added tungsten. That's the tungsten. That's the reason why there's tungsten there. It's an insulator, and it's also a densifier to the carbon. I mean, not carbon. Ceramic that is electrically conductive, but also very insulative because of the tungsten and resultive properties there within. So like it should work, but then. Because I didn't use aluminum. I used like a magnesium aluminum, probably with a carbon interspaced with a most likely silicon beryllium design, which would work out well enough and be electrically conductive, and has tungsten as the insulator, which would be a densifier for it, while still actually maintaining structural, bendiness to a point. Then it like is a non-Newtonian. If you don't know that oil is non-Newtonian, that's electrically conductive. Which even with all those little strands, and like that strand, that explains something then, because it's like, right, that was actually glass that's interspaced with the electrically conductive plastics. And so with the correct doping of that glass, it's now electrically conductive, insulative, and it can be used as a coil in its own right when it's wrapped around, and then has a through that's still stretchy and bends, like fiberglass. That also happens to allow for the transfer of electrons in their fields, in the charge fields, through the sinew, so to speak, for the muscle, and then the bone as well, which, if done with the proper placement, it then creates its own version of a spread out or concentrator, or for me, my purposes, it's a capacitor amplificatory circuit for the degree of those doped paint, copper, water inside woven skin that is sealed, and then is also able to heal itself, and then allows for electricity from pressure, heat, and wind to be transferred along with movement, because like it'll extend that movement because it'll usually spread out, but then like that helps kind of concentrate it and seal it in a particular area, but then those electrons and everything, and so you get pressure where you should want it to be. But the caveat is when it exceeds a certain degree of accelerational force, it then turns into non-Newtonian, which is usually a good thing when it's a spacesuit, because micrometeorites or someone is dumb enough to try and fire a bullet at you. So right there, and same thing with the faceplate, is fairly dense, like it'll stop some rounds, you know what I mean? So yeah, and it bends and it flexes, and so like then you have the computer that's at the neck, and throughout the whole thing, that's an analog light sort of basic concept of like, oh, we're going to use the analog, we'll have these. If you know about the stuff called hashes, like there's a program that means it'll turn it into this. Well, a certain amount of light information that comes through is enabled, or your pressure or whatever, because it still has charge field, so like boom, 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 heartbeat and muscle movement and brain thinking process, and then you have the exoskeleton that's all around, and the ability to just zip it in and off, which, there you go, right? But then that means, like, as it goes and filters through, it then takes that information and is able to interpret that bit or byte, that 1 or 0, in a AC version of a line that then has a increase for the sine wave, or a decrease, meaning a 1 and 0, that then gets interpreted and then hashed out with a program that's put into its cache system to facilitate a logic gate matrix run through that allows for it to give you interpretable results for regular silicon-based designs. Now, pretty easy, simple concept. Then basically I made a charge field. I'll do another video. Give me a second.